Today, I have the unique opportunity to visit the Siemens Switchgear factory in Frankfurt. On my right is Florian Wolfram. He is portfolio manager at Siemens. On my left is Udo Straub. He is head of R&D for gas-insulated switchgear. To my first question, why is this hype around SF6 free switchgear in the industry?
I wouldn't call it hype. It's more the result of continuous research and development to which the industry already committed before. Latest innovations are showing that for all voltage levels of gas-insulated medium voltage switchgears, F-gas-free solutions are possible. The whole industry is focusing on this trend and fits perfectly to the current discussion of a sustainable future.
Udo, what is so special about your new solution?
The specialty is insulation and switching without F-gases. That means when we talk first about the insulation media, we see two trends in the market. One is going and taking the natural components of ambient air, which is nitrogen, CO2 and oxygen. And we see another direction in the market, which is using new synthetic fluorinated gas components. And we at Siemens, we have decided to go the path of how we call clean air, which is only using ambient air components for insulation.
What is the secret about this new approach?
The secret is basically our new blue switch. It's a load break switch, which is inside the sealed vessel of the switchgear, and it works in clean air. It's basically the heart of the switchgear. And it uses vacuum technology, which we are specialized in for many years.
Udo, how does this look like in detail?
If you look at the details, Thomas, you see this small vacuum interrupter, which is located in the auxiliary path of the load break switch. It opens up in the first couple of milliseconds and quenches the arc. Afterwards, the main contacts open up. And with this innovative design, we have been able to develop a new sustainable gas-insulated switchgear.
Florian, how does your new blue switch solution compare to a traditional switch?
For power distribution on secondary side, there are two common principles in use. One is the vacuum interrupter in the main current path, combined with a disconnector. Secondly, it's a three-position load break switch, which uses already SF6 to extinguish the arc. Tomorrow, we are using for this our new blue switch solution, which works perfectly together with clean air.
Which were the main challenges in the R&D process?
Good question, Thomas. Actually, there are three main challenges. First is arc extinction. Clean air has almost no arc extinction properties compared to SF6. Second one is available space. The task was to design the switchgear in the same dimensions as before. And the third one is isolating distance. Since SF6 has a 2.5 times better dielectric property than clean air, this was a main challenge. And in combination of these three challenges all together, this was really a hard nut to crack.
Udo, hand on heart, do we speak about a proven technology?
Well, Thomas, first proof point always in the research and development is to pass all the type tests regarding the relevant norms like IEC. Second proof point are internal test programs which really tested all the life situations of the switchgear regarding quality, safety and availability.
And what about the lifetime of the switchgear?
Talking about the lifetime, we have two aspects. First is we are using clean air, and this clean air is also in the field in other industries in combination with other materials. So we have no issues regarding material compatibility because these effects are known and are not a problem for us. And second aspect is that some of our visionary customers have GIS switchgear filled with clean air in the field for many years, and I can tell you they work perfectly.
Udo, what does this mean for the user?
Actually, let me explain this by an example from the automotive industry. When designing electric vehicles, The design engineers would never come up with the idea of exchanging the gas pedal and the braking pedal and put them on different positions, right? So same applies here for the switchgear. The operating philosophy remains exactly the same. So the user does not have to learn anything new.
My next question is about the end of life of a blue switchgear. What do you do with it afterwards?
Well, since we only use vacuum technology in the blue switch, there are no toxic decomposition substances created. And we're only using clean air for insulation, right? So there are no concerns regarding environment, health and safety issues. And no special end-of-life treatment is necessary, like gas recycling.
Florian, is your new Blue GIS solution compatible with standard substations?
Here I like to mention the footprint of our new and existing switchgears. Footprint is very essential where space is limited or very expensive. And this is why it was a main goal of our R&D development. And with all the innovations which we saw before, I have to say we made it. And it's now easy to integrate the new Blue GIS solutions within the existing substations.
We have to come to an end soon. So for a broader view, do you have other SF6 free solutions in your portfolio?
Well, we have our 12 kV products, the primary ADAB12 and the secondary switchgear ADJH12. With that both products, our customers gain positive experience so far. And we recently launched our NX Plus C24 and the Ringman unit for 24 kV will follow soon.